Okay dear students, welcome back. So in my previous video I was talking about Pauli's X gate and Y gate, and also what are the properties of quantum gates, why that quantum gate should be unitary and why it should be reversible. So ಬನ್ನಿ ಮುಂದೆ ಹೋಗೋಣ. We will now discuss with the Z gate, Pauli's Z gate. Z, when it operates on 1, what will happen? When operates on 0, what will happen? These are all 5 marks questions only. Well, when Z operates on ket 0, what is the result? So as usual, by now you already know how to find it. If you want, you can pause this video and try. Well, ket 0, Z, first Z is 1, 0, 0, minus 1, and when it is operated on ket 1, that is 1, 0, what will be the result? So I write here 1 into 1, 1, plus 0 into 0, 0, first number is 1 only. Next 0 into 1 is 0, minus 1 into 0, 0 only. So dear students, please permit me to skip some steps which are already familiar to you. Okay, well, so this is 1, 0. So I operated on ket 0, I got 1, 0. What is 1, 0? It is nothing but 0 only. That means when Z operates on ket 0, it gives ket 0. That means ket 0 is unaltered when Pauli's Z matrix operates on ket 0 state. Well, this is first operation. Second operation, let me try Z on ket 1. What will be the answer? What will be the answer? Z is as usual 1, 0, not 0. It is 1, 0 and 0 minus 1, this one, that is a Z, into ket 1 now. Ket 1 is here 0, 1. Let us see what will happen. 1 into 0, 0, plus 0 into 1 was 0. So first number is 0. I repeat once again. 1 into 0, 0, plus 0 into 1, 0. So 0 plus 0 is 0. Well, 0 into 0, 0, minus 1 into 1, it is minus 1. Look at this, dear students. This is nothing but minus. If you take minus common factor, it will be 0 and 1. That means when Z operates on ket 1, it won't give you simply ket 1, it will give you minus ket 1. So it will change the phase of the ket 1. So it was plus earlier, it will now minus. So this is the effect of Z gate on ket 0. So now you try on the superposed state. That means when Z operates on ket psi, what will happen? So I write Z, that is 1, 0 and 0, 1, 0 minus 1 on psi. Psi is nothing but alpha and beta. So finally it is going to become 1 into alpha plus 0 into beta, that is alpha plus 0. First element is alpha plus 0. Next 0 into alpha, 0, minus 1 into beta, minus beta. So it is minus beta. Correct? That means finally alpha ket 0 as it is, but beta will now changes to minus beta ket 1. So this is when Z operates on ket psi. Okay, dear students, now write the truth table. Truth table, I write it here. Well, input, output. Input, if it is ket 0, output is also ket 0. Ket 0, ket 0. Input, if it is ket 1, input if it is ket 1, output it will be minus ket 1. Okay. Input, if it is psi, that is alpha ket 0 plus beta ket 1, output will be alpha ket 0 as it is. Next it will be minus beta ket 1. So dear students, I have explained Z also. Please write the circuit symbol of Z gate. It will be definitely Z like this, and this is input, this is output. So this portion you have to write here, this portion you have to write here. Just because of shortage of space I am not writing, but I hope you are able to manage now. Okay. Now look at X or Y or Z. Recall the truth tables. I display truth tables here. Look at X gate, Y gate, Z gate. What they are doing, they are taking either 0 to 1 or 1 to 0, or times 0 as it is, take 1 to minus 1 or I into minus 1, something like that. They are not able to take the states from 0 and 1 to any other states other than ket 0 and ket 1. Okay, so you cannot go beyond ket 0 and beyond ket 1. So therefore, Pauli matrices, Pauli gates, they have got limitations. What limitation? Either you get ket 1 or ket 0. ಅವೆರಡರ ಮಧ್ಯದಲ್ಲೇ ಓಡಾಡ್ತಾ ಇರ್ತೀರ ಹೊರತು ಅದನ್ನ ಮೀರಿ ಮುಂದಕ್ಕೆ ಹೋಗಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ಯು ಕೆನಾಟ್ ಗೋ ಬಿಯಾಂಡ್ ket 0 and ket 1. ಸಿ ket 0 ರಿಮೈನ್ಸ್ ket 0, ket 1 becomes minus ket 1. ಅಥವಾ x ಗೇಟ್ ಅಲ್ಲಿ ket 0 becomes ket 1, ket 1 becomes ket 0. ಈ ತರ 0 to 1 ಅಲ್ಲಲ್ಲೇ ಓಡಾಡ್ಕೊಂಡಿರ್ತೀರ ಹೊರತು ಮುಂದಕ್ಕೆ ಹೋಗೋದಿಲ್ಲ. Therefore, Pauli gates are not of much use. So we need some intermediate states. For that, we have to look for some other alternate gate. Now comes one such alternate gate. It is nothing but Hadamard gate or H gate. And as I already told, these gates are represented by transformation matrices, and these transformations are unitary in nature, reversible in nature. So Hadamard gate matrix form, we give it like this: H is equal to 1 by root 2 1 1 1 minus 1. So nobody will ask you how this Hadamard gate is obtained. There is explanation, but for this level it is not that important. If you can remember this matrix, it is more than sufficient. So now let us operate H on 0, H on 1, H on psi. Like I did H on 0, sorry, Z on 0, Z on 1, Z on psi. I will do it now. So okay, Hadamard gate, next part, I operate H on 0. What will happen? H on 0 means 1 by root 2 into 1 1 1 minus 1, that is my H, and 0 will be 1 0. Correct? Now simplify. That is equal to, well, I will try to accommodate if possible here. If possible, I will try to accommodate. 1 by root 2 will be there as it is, 1 by root 2 as it is. Now let us go ahead. 1 into 1 1 plus 1 into 0 0. So first member is 1. Correct? Next, 1 into 1 1 minus 1 into 0 0. Second member is also 1. Got it? Look at this. It is 1 by root 2 1 1. So that means alpha is 1, beta is 1 into 1 by root 2. That's not 1. I told you, no, alpha cannot be 1 when beta is 1. Beta cannot be 1 and alpha is 1. Alpha alone can be 1, beta alone can be 1. Both of them cannot be 1 at a time. So here, this is alpha position. Okay, I will come to that later on. Alpha position is 1 by root 2. Beta position is 1 by root 2. That means when H operates on 0, you will not get 1 ket alone. 0 ket alone. You will not get 0 ket alone. Like it happened in case of Z. Z when operated on 0, you got 0 alone. 100% 0. No, it is not 100%. Ket 0 divided by root 2 it is. Alpha is 1 by root 2. Actually it should be alpha ket 0. Aita? Plus I should write beta ket 1. That is ket 1 into beta. Beta is also 1 by root 2. That means when H operates on ket 0, it generates ket 0 plus ket 1 divided by root 2. This is nothing but ket plus state. I already mentioned this in one of my previous videos. Look at this. See the difference. When Z operated on 0, Y operated on 0, athwa X operated on 0, we were able to generate only one state, either ket 0 or ket 1. Now we have superposed state. 50% in spin up state, 50% in spin down state when Hadamard gate operates on my ket 0. Correct? So 50% because 1 by root 2 whole square. This is also 1 by root 2 whole square. Why 1 by root 2 whole square? Sir, we know already, because it is alpha square plus beta square. See, alpha square plus beta square, 1 by root 2 whole square plus 1 by root 2 whole square always is going to be 1 only. That's why the matrix must be unitary. Matrix must be unitary. Okay, let us take up another operation. So here I operated H on ket 0. Now I operate H on ket 1. Let us see what will happen. Same matrix 1 by root 2 into 1 1 1 minus 1. When it operates on 0 and 1, let us see what will happen. 1 by root 2 will be as it is. 1 by root 2 will be as it is. Okay, now 1 into 0 0 plus 1 into 1 1. So first element is 1. 1 into 0 plus 1 into 1. Next 1 into 0 0 minus 1 into 1 minus 1. So this is minus 1. Please follow carefully, dear students. Earlier I got 1 1, now I am getting 1 minus 1. That means ket 0 state is positive, ket 1 state is negative. That means when H operates on 1, it is going to generate ket 0 minus ket 1 whole thing divided by root 2. Whole thing divided by root 2. So this is the Hadamard gate operation. So this will generate what is called minus state. Like this generates plus state, this generates minus state. Okay, so individually operated on alpha, 0 ket, individually operated on 1 ket. Now you operate on psi ket. Psi ket, always 3 things we have to do. Ket 0 separate, ket 1 separate, ket psi separate. That is H psi ket is equal to what? Simplify. H is already there. 1 by root 2 into 1 1 1 minus 1. Psi is already there. Psi is nothing but alpha beta. It is alpha beta. Well, simplify further. That is equal to 1 by root 2 as it is. 1 into alpha alpha plus 1 into beta beta. So first one will be alpha plus beta. That means plus state. Next, obviously alpha minus beta. Please check. 1 into alpha alpha minus 1 into beta minus beta. That means you are going to have alpha plus beta into ket 0, right? Alpha plus beta into ket 0 divided by root 2 minus athwa plus alpha minus beta ket 1 divided by root 2, right? Now you take all alpha one side, all beta one side. All alpha means alpha 0, alpha 1 plus, that is alpha into ket 0 plus ket 1 divided by root 2. Okay, next take beta one side. I take beta plus beta ket 0 minus ket 1 divided by root 2. Okay, so that is alpha. This whole thing I can write it as plus ket. Whole thing I can write it as a plus ket plus beta. This whole thing I can write it as a minus ket. Okay, so if your input is alpha ket 0 plus beta ket 1, output will be like this. Now you design your own truth table. Your own truth table looks like this. So this is input, this is output, ket 0, please write this whole thing, that is plus, ket 1, write minus, this minus. Next, this one, actually because shorter space I am not writing, but please remember this whole thing you should write here, this whole thing you should write here. Or if you have enough space, plus ket you can expand. What I mean to say, instead of plus ket you can write ket 0 plus ket 1 divided by root 2. Full kuda bariಬಹುದು ನೀವು ಅಥವಾ plus ket ಬರೆದರೂ ಕೂಡ it is acceptable. So that is the Hadamard gate's role. Hadamard gate will take ket 0 to plus state, superposed state where alpha is 50%, beta is 50%. Similarly, when it operates on ket 1, also it will take to 50% only, but it is negative state. Okay, so this is about Hadamard gate. Now we will move on to another gate called phase gate. It is also called as S gate. I will take up it now. Okay, now comes phase gate or S gate. S gate or phase gate or any other gate what I am discussing right now are quantum gates only, and they must be in the form of unitary matrix. because they are going to transform the quantum state 0 and 1 to some other state. Even if it takes to some other state also, finally I have to get the modulus of probabilities should be, modulus square of the probability should be equal to 1. That's why matrices must be unitary. Well, I write, if you want you can check that previous one H, what I wrote, no H, or even Z. Z I already verified, Z is nothing but Z dagger only. Okay, now I come to the next gate called phase S gate. It is given by 1 0 0 I. Dear students, I give you one assignment. Please check whether it's Hermitian multiplied by with S is going to give you identity matrix or not. That means whether S dagger is equal to I or not. Please check. You know how to find S dagger? I'm just revising. Write the complex conjugate like 1 0 0 minus I. Then you change the row into column, means take the transpose. 1 0 make it as 1 0, 1 0 make it as 1 0. Next to 0 I should make it as 0 minus I. Okay, so row becomes column, column becomes row, that is transpose. So complex conjugate plus transpose is going to be Hermitian. That Hermitian multiplied by S, if it is going to give I, that is what is called inverse identity, then it is unitary matrix. S is unitary matrix. You can try this. It's a small assignment. It's a small numerical also. You can expect this for 2 to 3 marks. Okay, now let us proceed. First question as it is, as usual, what happens when S operates on Z0 ket? S operates on 0 ket, what will happen? Next we will try S operates on ket 1. Next we will try S operates on ket psi. Here I wrote it for Z, now I am trying for S. Already I discussed for H also. Barana bani, S is equal to, S ket 0 ಏನಾಗುತ್ತೆ ಅಂತ. Well, I write it as 1 0 0 I into ket 0. Ket 0 means 1 0. This is my ket 0. That is equal to 1 into 1 1, 0 into 0 0, 1 plus 0 0. 0 into 1 0, I into 0 0, that means 0 only. Means when S operates on ket 0, no change in the state. It remains as it is. Well, what happens when S operates on ket 1? Well, it is 1 0 0 I into 0 1, this is my ket 1, that is equal to 1 into 0 0 plus 0 into 1 0, first element is 0. Next 0 into 0 0, 1 into I, so the second element is I. Dear students, I am not going in detail about the multiplication of rows and columns because it is now our familiar concept. Okay, well, this is nothing but I into 0 1, that means I into ket 1. So when S operates on 1, it changes the phase. So it is I into ket 1. That is why it is called as phase gate. Right? Well, let us try the third one. Third one is S operating on psi. What will happen? That is 1 0 S 0 I into alpha beta, because psi is nothing but alpha beta column vector, that is equal to what? So that I will write here 1 into alpha plus 0 into beta 0, first element is 0, 0 alpha 0, I into beta I beta, correct? So this is what I am going to get. That means when you have alpha ket 0 plus beta ket 1, when S operates on this, you are going to get alpha ket 0 as it is plus I beta ket 1. You will not get beta ket 1, instead of that you get I into beta ket 1. Now the truth table, well, whatever I have written you just summarize. It is going to be the truth table. Input, output. Input is 0, output is also 0. Input is 1, output is I into 1 ket actually. Input is, okay, you write this full thing as input, that is alpha ket 0 plus beta ket 1 as input. Output is this full alpha into ket 0 plus I into beta ket 1, this is the output. So this is the truth table for S gate, that is a phase change gate. And if you want to write a symbolic representation, very simple, write S here, output, input. This whole thing will write here as input, this whole thing will become output here. So this input here, so this whole thing should write here, whole thing should write here. So this is the symbolic representation of S gate. Now I have come to the end of single qubit gate with the last gate, which is T gate. So now I take the last gate, that is T gate. What is this T gate? As usual, it is also a transformation matrix, and it is represented as T 0 0 0 e to the power of I pi by 4. Sorry, this is not 0, this is 1 0 0 e to the power of I pi by 4. Now let us operate T on 0. What will happen? When I operate T on 0, that is 1 0 0 e to the power of I pi by 4 into 1 0, that is my ket 0, that is equal to 1 into 1 1, 0 plus 0 0, so first element is 0, 1, the first element is 1. Next 0 into 1 0, e into 0 0, second element is 0. That means there is no change in the state. T ket 0 remains ket 0 only. So when T gate operates on ket 0, no transformation. The state of the particle remains same only. If it is in spin down state, it remains in the spin down state only. Let us see what happens. Okay, if T operates on ket 1, so same method. By now I hope you already familiar how to do the calculations. 1 0 0 e to the power of I pi by 4 into 0 1, that is my ket 1, is equal to 1 into 0 0, 0 into 1 0, first element is 0. Next 0 into 0 0 plus e to the power of I pi by 4 into 1 is e to the power of I pi by 4. So you take this e to the power of I pi by 4, then you will end up with 0 and 1. This is nothing but e to the power of I pi by 4 into ket 1. That means when T operates on 1, it will transform the ket 1 into this form. Okay, dear students, I give you a small assignment. Try what happens if T operates on psi. What will be the answer? And also write the truth table for this. Also symbolic representation for this. I just write the truth table. Check. I input, output. Input ket 0, output ket 0. Okay. Input ket 1, output e to the power of I pi by 4 ket 1. Similarly, write the last one, that is alpha ket 0 remains alpha ket 0 plus beta ket 1 becomes plus e to the power of I pi by 4 into beta into ket 1, right? So this is the truth table. Please small congestion is there. Try to distinguish between the previous write-up and the present write-up. Okay, dear students, finally T gate, I write it like this. This is the output, this is the input. In the input portion you write this one, in the output portion you write this one. That is going to be the T gate. I hope you are enjoying my videos, because I am receiving a lot of positive comments and very good feedback I am receiving from both teachers and the students. So keep encouraging me. I will come back to you with many more videos on many more topics. Okay, so till then, thank you very much.